from the mountains to the prairies to the ocean wide with foam. God bless America, my home sweet home. God bless America, my home sweet home.
Ladies and gentlemen, welcome to Job Shop USA. My name is Keith. Today we're going to share a customer of ours, and he is an RC enthusiast, and we have an RC motor here, desert aircraft, and he's adapting, or he wants to adapt this engine to his aircraft. And of course, the frame adapter from the motor to the frame, it does not fit. So we're here to make him one that will fit. All right, our customer came by with this, and the day he came by, we run this through a two-step CAD. Okay, so here's my CAD drawing. This whole pattern that bolts to the motor itself, we're going to maintain that, and we're going to maintain this circle in the center here, and we're going to change this pattern on the outside of this aluminum plate to the configuration needed, the 3.5 by 3.25, which is the bracket or the mounting area on the frame of the airplane itself. Now, we had to, they were rusty, so we had to heat this back here with our torch, and we took them off, and there was really a lot of rust build up here, and that was the main reason. He had thought that maybe Loctite was holding them in there, and that's why I used the heat. But it did need heat to expand them so that we could take them out without damaging the Allen section there. All right. So this plate is pretty simple. 4 countersink holes, 4 straight drilled holes. The thickness of this is just about 209 thousandths. All right, so we take our part and we take our first step CAD drawing, we go into the computer. Okay, so once we take and we put our dimensions in here, we actually come up with our flange. Now, we don't need to make this into 3D because that's not how the cam setup for the water jet performs its task. So we need to just bring it in as a DFX. So we take it and we go ahead and we create or export, and we export this as a DFX into our memory stick. All right, we open the WAM program, which is the cam for WAZER, and we import our file that we have in on the USB. There's our part there, and now we're going to move it. We've been picking different spots on our table out there so that the cut or the platform that the cut's being performed on is kind of like the grate on the plasma cam or any other support for a cut that affects everything below the cut as well. That the surface that you're holding it eventually gets deteriorated, so we space it out and move it around. Uniform consumption gives you a longer duration of your support bed. So that's where I'm going to choose to put this today, and I kind of got it circled in on the center of that crisscross right there. All right, so we're happy with scale and position. We're going to check metals, so we're going to hit here aluminum 6061. Right here's a 1/4 inch on the thickness. We're good there. Okay, We want our cut paths on the outside and tabs. We want to eliminate all tabs. These you kind of learn after a little bit what parts are going to fly out and maybe get stuck somewhere. And we feel on this 1/4 inch material, the thickness here, the force up from the bubbling and stuff underneath should be able to fly pretty good without having any tabs. But if you had a really light, really thin wafered part, it might fly away with the pressures built up in the cutting machine there. Then you would want to put some tabs in there. All right, and we're just going to move on. We want this. We have 3 settings that we can choose: coarse, medium, and fine. And the coarse estimated time is 57 minutes and about 19 pounds of material. The medium setting is 102, an hour and 2 minutes and 20 pounds of material. And the 5 is an hour and 9 minutes and 23 pounds. So basically you kind of go like this. The reason why I'm going to choose the fine is because I'm looking for a finish that's done when we're done. And also, sometimes when I've chosen a coarser cut, it is a little bit coarser, and then I have to do a little bit of manipulation to the surface to be satisfied. So we're just going to start off because I'm going to outweigh that couple pounds of material and 9 minutes longer. So we're going to generate the file, and we're going to go ahead and we're going to call this airplane mounting plate. All right, there we go. We're going to save it. All right, we're just going to double check and make sure that I did save it in there. Okay, and it is in there. All right, let's go ahead and eject that. All right, it's ready to go. We have it here. Let's go cut it out. We filled the grit, which is the material that makes the cut itself with the water pressure, of course. And we'll put in our memory card here. And we're going to select the file. Airplane mounting plate. All right. Okay, that's the same little cross there that we wanted to put the material on. So we have a drop from our plasma cutter, and I think it's going to make the part just fine. Here's the, actually it went this way here, but it's going to be a little wider and a little different configuration. So I'm pretty sure that this plate will still handle the size, and we will be able to do that in a cross check after we start our process here of locating and all of that. All right, I'm going to get my screws and put that down in place. I think that's going to be good enough. All right, let's go ahead and we'll hit OK on there. Prepare the machine. We did. Lift nozzle. All right, so it's going to go over here to this position here. And now it's going to come over to a location that's relating to where the cut is for this part. Okay, set the nozzle height. I kind of went through the other stuff. It just basically says you got the material set up and you got all this, that, and everything. All right, we set the nozzle height. Press OK. Now we're going to go ahead and we're going to make a dry run. So it's going to cut out the center hole first. Hit that hole. Hit that hole. Okay, now we're looking for the outside. Just want to make sure that that's all on our plate. You know, it looks like we're all on there. This is the closest corner right here, but I'm still sure that we are cutting on this plate here. All right, I'm satisfied with that. I want to go ahead and mount my GoPro 11, which is waterproof, and I made a mount over here. So we're going to mount this in here. I'm going to go ahead and catch a time-lapse video of this. Okay, max time lapse. That's where it's going to be at. Okay, all right. We're going to go ahead. Well, we got to give this thing power first. All right. Connecting. Good to go. All right. Now we close the lid and press start to go ahead. All right, we'll come back to this when it's done, and the time lapse should give us a pretty good view of how it cuts for the duration of the cut. right, this says 99% done, so it is almost at the end of the cut here. All right. All right, we'll turn off our time lapse here. All right, let's wash down a little bit here. All right, cool. Let's raise up the head here. Move it up out of the way. First thing I want to do is bring in the sample. Now, remember I said this was 200,000 thick, and this is 1/4 inch plate there. So we're going to be happy with the, okay, the mounting holes line up. And you can see the difference in the spread there of the new hole pattern. All right, let's see if we can pop this out. Center pops out. Where it started and stopped right there to add material, and so there's a little tang on there. So we're probably going to pop this thing loose, and then we'll be able to press it out of there. All right, there's a little tab that was holding it on there. A near complete plate. A little softness on the edges, and go ahead and countersink those inner holes, and then just give these holes a light chamfer. Let's go do that now. All right, I just got a little flapper here, and I'm just kind of softening that edge around here. That was where that pierce was, and then there's another one here. All right, looks pretty good. Let's do the inside circle. Okay, that looks pretty good. All right, now let's just break or chamfer all the small hole diameters. We're just going to put small chamfer in the drill chuck here. Okay, now we just want to make sure that these holes will pass same size hole fastener through those, and these were 1/4 inch. Here's a sample. All right, it's a little teat, so we'll go ahead. We're just going to use this, hold it down flat to our surface here. And we're just making sure that we have clearance and that those holes are going to fit the bolts. All right, now these smaller holes, which are only about 4 thousandths, 5 thousandths smaller, we're going to go ahead and check the fit on those. All right, the countersunk, we're going to do that in a minute, but we want to make sure that the actual hole is the right size. So we're going to take the reamer for that bit. All right. We figure out a countersink. This is going to be a full depth on this little countersink right here. Full depth with it gives it the right depth. Bring it up here to where we're more comfortable with it. Okay. All right, that looks good there. And I set to 0. Let's check it with a screw. Okay, below the surface, that's all we care about. Okay, check the first one, and we check the last one. We're good. All right, let's go check the fit. Okay, old one, new one. Looks good on there. Okay, let's screw this in here with a... That's a good sign. That's another good sign. That's a really good sign. All right, and then these are accessible through here, just inside the mufflers coming underneath the motor there, under the heads. Awesome. I think we got a winner there. All right, I hope you enjoyed another project here on Job Shop USA. A little bit of water jetting, a little bit of machining, couple stages of CAD drawing, and a couple files shifted around. We got this customer what he wants, and that's the most important thing. Till next time, get her done.